Welcome back to Podcast Name, where we dive into the fascinating world of technology and innovation. I'm thrilled to have you here today because we're about to explore a cutting-edge topic that's revolutionizing how we think about image generation: denoising diffusion models. Now, you might be wondering, what on earth is a denoising diffusion model? Well, stick around and we'll break it down together. So to kick things off, let's start from the ground up. Denoising diffusion models are a type of generative model, which means they can create new data instances that resemble existing data. The beauty of this approach lies in how it gradually transforms random noise into a coherent image. Imagine sculpting a statue from a block of marble, where initially it just looks like an unshaped mass. It's all about refining that chaos into clarity. In a recent project, someone found the existing resources on diffusion models a bit overwhelming. So they decided to refactor a popular implementation, creating a simplified version in PyTorch. This repo is not just a code dump, it's a learning tool. The goal? To turn the complex into something digestible and useful, especially for those looking to understand the key components behind these models. Let's break down the structure of the code. It's organized neatly into different files under the sarc folder. For instance, you've got funcdiffusion.py, which contains all the critical functions for the diffusion process, handling both the forward and backward flows. Pretty essential if you want to get into the nitty-gritty of how these models work. Then there's clsdataset.py, where they focus on the data aspect. They worked with a specific class, a goldfish, known scientifically as Carassius auratus. It's quite amusing because the data augmentation techniques they used, like rotations and flips, sometimes resulted in upside-down fish in the generated images. This little quirk adds a lighthearted touch to some technical work, don't you think? Now, another interesting part is clsmodel.py, which, to be honest, mostly duplicates a more complex implementation, but comes with some tweaks, like changing out the channels for RGB images, a big deal for color fidelity in generated visuals. It's fascinating to see how these simpler adjustments can really make a difference. And of course, we can't forget about the training part. The main train-diffusion.py separates training and generating tasks, making it clearer what parameters you really need for each process. This freshness and organization is something I believe is often overlooked in coding projects. On the flip side, if you're itching to see what these models can actually create, there's main-generate-images.py. This script uses the trained model to generate images, and let me tell you, the results are a mix of impressive and comically flawed, thanks to those fun data augmentations. As we dive deeper into this technology, the key thing to keep in mind is that while generated images may not yet reach the crisp quality of real photographs, it's the exploration and improvement that makes this field exciting. Every tweak, every method learned, as seen in Phil Wang's more intricate repository, adds layers of complexity and potential improvements to the model. So, as we wrap up today's discussion, let's reflect. Denoising diffusion models present a remarkable journey from random noise to reality, inviting us to tinker and create. If you're intrigued by generative modeling, remember that every complex implementation started as a simple exercise in learning. So what will you create next? Thanks for tuning in to Podcast Name. Until next time, keep questioning, keep exploring, and who knows, your curiosity might lead to the next big innovation.